you all learned how to take y and x, how to take an equation, x, trying to think of a grade 10 question. X plus 4. No, I don't like that. 3x plus 4y minus 6 equals 0. You all learned how to take that and put it on a graph. And it made a nice straight line with x-intercepts, y-intercepts. And you learned how to do that by moving it into slope-intercept form and all that, yeah? That will give you a straight line. If you were in my honors class, you learned that the next thing you were going to do is how to take something on this graph and graph a curve. This is what we are doing now. This is pre-calc 11. And this is what is called, a linear function. And this is what is called a quadratic function. Okay? A quadratic function is what we are going to spend our time working on right now for the next little while. So we will begin with quadratic equations. First of all, we have to explain what a quadratic equation is. So, a quadratic equation. A quadratic has variables. We will use x and y. Okay? Has a maximum exponent value of 2 for the independent variable. Actually, I'm going to write out independent variable. For the independent variable. And in our case, independent variable. Now, if you were in my grade 10 class, you know that the independent variable has a whole bunch of names, yes? It is also the input. So I'm going to use independent variable and input, and it is also, in our case, the x value. Maximum exponent value of 2 for all those things. All right? That's what it means to be quadratic. So I'm going to write out in red what a quadratic is. X squared plus 7x plus 12. That is a quadratic. Why? Because the x value has a maximum exponent value of 2. Everybody cool? Easy peasy lemon squeezy, right? Now, you guys are smart kids. We are working with quadratic equations, aren't we? What is an equation? Right. An equation means I have a math thing which is actually called an expression that equals another math thing, which is another expression. So this right now is not a quadratic equation, is it? But once I do this, it is. Everybody cool? Once I have an equal sign, this I can simplify. This whole thing I can solve. Do you understand the difference? Yeah? Everybody's cool? Okay. Now, just like in linear functions that you did last year, ax plus by plus c equals 0 is general form. Quadratics have a general form as well. The general form, so this is the form with which we will work, is ax squared, because it's got to be an x squared, plus bx plus c equals 0. And a, b, and c must be rational. Is everybody good? That's a bunch of terminology, a bunch of vocab, blah, 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 blah. We're going to start using it right now. But everybody has seen all of this between grade 10 and now. So none of this is news to anyone. Cool? Okay, let's work on actually solving these. And you already know how to solve them from the radical unit. You think you don't, or you might have forgotten, but you actually already know what to do here. Okay? So I'm going to write something right here that illustrates the zero product property. All right? A times B equals 0. What does that actually mean? What does this mean in English? What is A, Lucas? Yeah, A or B has to be 0, doesn't it? They are both unknown numbers, and to make this true, one of them has to be 0. The other one can be anything else, yes? So this actually means A or B must be 0 to make this true, yes? Everyone understands? So what's that saying? What that is saying is if I have factor 1 times factor 2 equals 0, then either factor 1 or factor 2 must be 0. Does everybody follow that step of logic? If it's just single numbers, one of them has to be 0. If they're factors, one of them has to be 0. Is everybody still cool? So now let's take this knowledge one step further to this. X plus 3, x plus 4 equals 0. What does that mean? What is this? That is A, correct? What is this? B. So following what we know, if this is true, then either x plus 3 has to equal 0, or what? X plus 4 has to equal 0. So what are our two possible answers here? -3 or -4. Is everybody cool? It's not that complicated, right? Kelvin? I'm about to show you. When x is -3, what did this mean in grade 10? What were we allowed to do with that -3 last year as soon as you figured it out? Plug it back into the original equation, yes? Great. So that means, and I'm going to work in yellow because we're working with the yellow variable that I did here. So what that means is I have -3 plus 3 times -3 plus 4, right? What's -3 plus 3? 0. What's -3 plus 4? 1. What's 0 times 1? Did it work? Yes. Cool? Now, if I change to the blue one, and I come over here, I have -4 plus 3 times -4 plus 4. -4 plus 3 is -1. -4 plus 4 is 0. Does that equal 0? So they both work. Does everybody understand? Now remember, in the radical equation section, we had to check them both because some of them might not have worked. Yes? Here we're checking to make sure they work. It's the exact same thing. Is everybody cool? Okay. So we are going to use factoring to solve this, because hopefully some of you made this connection. Right? Now check. What's negative 3 squared? 9 plus negative 21 is negative 12, yes? Negative 12 plus 12 is 0. What's negative 4 squared? 16 plus negative 28 is negative 12. Plus 12 is 0. Cool? All right, so now on to your next page, you see 3 quadratic equations. Yes, Nav?
So basically, in such an equation, both of them should usually work.
Yeah, in math class, both will work. In reality, when we are using these to model reality, they might not both work. Let me give you an example. It's got nothing to do with what we're doing right now, but let's pretend I'm graphing a curve of time. Could I ever have a negative answer? Why? Time can't be negative. Do you understand what I'm saying? So in math class, quadratic equations have 2 answers. Once you use that equation to model something in the real world, then you have to make sure if those answers are going to work. Which is why I do radical equations, which shows you that sometimes one of the answers doesn't work, before I do this, which shows you again that sometimes one of the answers doesn't work. Okay? All right, so let's look at this first one. It's good practice for tomorrow. What do you got to do? You're going to factor that however you like to factor. I don't care what you like to do, but the answer is x plus 7, I lie, x minus 7, and x plus 2. Yes?
Yep.
So what are our answers?
Negative
X must equal negative 2 and positive 7. Cool? Easy to check. 4 plus 9 or plus 10 is 14. 14 minus 14 is 0. Right? How are you going to factor this one? Again, you choose your method. Now, I am going to do something here that I don't normally do. Okay? I am actually going to give you a preference for the way to do this. When I factor this type of thing, right, I don't use the box that Peter and a bunch of the rest of you use. I use my thing where I multiply this by here, right? And that gets me some fractions, yeah? So if I were to work this out, I would need to multiply to negative 15 and add to positive 2. What is it? If we were doing this my way, what are the factors of 15 that add to 2? 5 and 3, right? Positive 5 and negative 3, yes? So this would be x plus 5, x minus 3, and then I would remember that this is over 3. Everybody cool? Now, normally, I would take this 3 and move it to the front, wouldn't I? That's the way I personally factor. And I would simplify this to 1, yes? Don't write this down. Just look up here for a minute. If I finish this factoring the way I do it, I would get 3x plus 5 and x minus 1, wouldn't I? And then I would have to do this thing, where 3x plus 5 equals 0. Okay, so that comes over there, minus 5. 3x equals minus 5. X equals negative 5/3, yes? Everyone agrees? Okay, but look. Did I ask you to factor this, or did I ask you to solve it? Solve it. Look at what happens if I stop right here. Negative 7, the answer was positive 7. Plus 2, the answer was negative 2. plus 5/3. So what's the answer? Negative 5/3. Minus 1. So what's the answer? Positive 1. If you do my method, you can stop there because, is everybody cool with that? Now, if you don't like my method and you actually factor, then all you have to remember to do is solve these. And once you've done it once or twice, you're going to see it automatically anyway. Cool? So, what are we going to do for this one? You're going to factor it again any way you want. I, of course, factor it as multiply to 4, add to 2. Add to 4, I mean. So what is it? 2 and 2. So it's x plus 2 over 4. And x plus 2 over 4, which I know simplifies to 1/2. They're both plus 1/2, so x has to equal negative 1/2. Now, what's weird about this one as compared to that one and that one? There's only one root. Why? Because this factors to x plus 1/2 squared, doesn't it? And since it's squared, it must have the same root. Cool? Practice on those 6. Go. Yes? You would leave that in a fraction. You're going to be leaving almost everything in fractions for the next little while. Don't bother with decimals until like 3 lessons from now. And you'll see why. So those first 6 are real easy, right? Because it's just single digit. What have I done to try to mess you up? A, M, B. Does that matter? Of course not. Your final answer is going to be B equals A equals or M equals instead of X. Okay? The letter doesn't matter. Actually, you might as well just do that whole page. That's your practice right now. When you finish page 72, have a break, take a stretch, have a pee, get a drink, do what you need. But do page 72. For 2 reasons. 1, it's good practice for tomorrow, and 2, you need to be good at this to do the rest of this unit. Last time I'm going to interrupt. Is it okay for the first A, B, C, D, E, and F that I just write the answers? You guys don't need to see me factoring those kind, do you? Everyone's good at factoring them, right? Well, when I write it all out, it'll be... Oops. Hey, Mr. Peters. I just started re-recording, so she only heard, that's what my wife does. She would think it was a compliment. Not that she watches the videos. She makes fun of my videos. She says I'm too loud on them. She says I sound aggressive. No. I said it's because I'm right by the microphone and I have to talk to the kids in the back. What I really need to do is hire a broadcasting student to stand over here with a boom mic for the whole class. That would be so wicked.
Just for one game.
Well, like, I know there's other classes that can hear you down the hallway.
Yeah.
You're talking for.
I don't care about them. Remember last year when I had my big FM microphone from Fan B?
Oh, yeah.
I love that thing. Well, I didn't have to be as aggressive because the microphone was right here. So I could just talk like an FM DJ. But I can't now. I got to yell. Anyway, so I'm re-recording. It's all there now. Everyone's cool? No, I didn't. My kids live the story. They don't need to hear that story again.
Your kids watch your videos?
They will. I'm leaving them on YouTube because sooner or later they'll be in math class. But 1D. I did do 1D. My $4,000 computer erased it. Because, my $1,000 computer last year almost never did that. My $4,000 one that's better does it every single day, all the time. All the time.
It knows that you didn't really want that day.
Okay, is everybody good? Okay. Now, like I always do with math, I show you something that is so easy. You all promise me you get it, and then we add one wrinkle. Let's add that wrinkle. What is different in A?
We just have to make it equal.
It's expression equals expression now, isn't it? What do we know what to do when it's expression equals 0, yes? Do we know how to make this equal 0? Of course we do. We move everything. So, does it matter to which side we move things? No, it does not. But I highly recommend that you get your quadratic term to be positive. So is my quadratic term positive here? Yes, so I don't want to touch him. Everything else needs to move. So I have 8x squared. Are there any other x squareds? No. So he's not moving. Minus 5 equals 10x minus 2. Well, this 10x can't be there. So if we were in Mrs. Bad Crumble's class in grade 6 learning algebra, we'd go minus 10x. And then we'd minus 10x from this side, wouldn't we? But we're not in Mrs. Bad Crumble's class. We're in Mr. Myers' grade 11 class. So we're just going to move it over the equal sign and change the sign, aren't we? Minus 10x. And what's this minus 2 going to do when it comes over? It's going to become plus 2. What's already there? Minus 5. So it's going to become minus 3, yes? And what is all that going to equal? 0. And then what are you going to do? The same thing you just did 6 times before. You took grade 9 math, collecting your like terms. You added grade 10 factoring here to do a grade 11 question, which gives you an answer of x equals whatever your roots are. Everybody with me? So you're going to factor that. What is it?
Club up in here.
6 and 4? 12 and 2? It is 12 and 2, except what? It's 12 and 2 over 8. You got to remember to do that, right? Which makes this 1/4. And it makes this 3/2, right? And one of them's positive and one of them's negative. Which is which? Positive 3/2 and negative 1/4. Everybody is good? I'll do this one properly. Remember, I find these easier to factor like me. So I have to multiply to negative 24 and add to negative 10. It's 12 and 2, right? Negative 12 plus 2. So it's x plus 2 over 8 and x minus 12 over 8. Then you simplify the fractions, 1/4. Simplify the fraction, 3/2. Then you can stop, because this would have to be negative 1/4 plus 1/4. There it is. And this would have to be positive 3/2 minus 3/2. There it is. Is everybody cool? Okay. What looks different on B? I just need to distribute. And then do what? The same thing. So we take a grade 9 topic again, we distribute. We take a grade 9 topic, we collect our like terms. We take a grade 10 topic and factor it. We take a grade 11 topic and actually give an answer. What is it?
I did that in my head. See, I'm learning. I'm really bad at those. I'm surprised I was able to, despite being super simple.
Of course you can get it slower. Just like you can run the length of the rugby field faster than me. You can't, but...
Mighty Mouse. Mighty Mouse known for speed, I guess not.
Mighty Mouse is known for singing opera and coming to save the day. Here I come to save the day. Mighty Mouse, I'm on my way. Who doesn't love Mighty Mouse?
Never watched it.
I don't think most
It's
people-
tough to find. Mighty Mouse is not, because it's not Warner Brothers. You guys are really only aware of Warner Brothers for old-timey cartoons, like Bugs Bunny. You're not very up on your Hanna-Barbera cartoons. You're not up on your Snaggletooth and your Yogi Bear, and you're not up on your Dick Dastardly and Muttley, and you're pretty weak on your the Grape Ape.
I don't know. Hanna-Barbera is still actually fairly common.
Yeah, but then there's nobody's up on Popeye.
Oh, I love Popeye.
Do you really?
I do. I watched that.
Who do you
lot.
know on Popeye? You know Popeye and olive oil. Who's the bad guy?
Bad guy.
Exactly. No. The bad guy is never Mrs. Bad Crumble. Mrs. Bad Crumble is good people. She's doing the best she can.
Teaches you bad math habits.
Wimpy, I will gladly pay you Tuesday for a hamburger today. Okay, so you guys should be able to do this. Where's the only one that's going to possibly give you a hassle? E and F should be the only ones that give you a hassle, yes? But they won't really. They will not really. What? Yes, of course you can.
Brought lots of physics logic into that question. Mostly because all the equations in physics require you to do that.
Is everybody good? Of course, that's okay. We have not gone over your radical test yet, have we?
Yeah, we did.
Okay. Have you seen it?
Yes.
Oh, okay. Look at the color of my hair. With every new gray hair, my brain turns slightly mushier. Huh? Yeah, I should have. See, that's the problem. All those stupid puzzle games didn't get sexy until I was too late for me. That's not true. I've done crossword puzzles my whole life.
I'm not very good at Sudoku.
I'm not very good at Sudoku either. You know what's funny? I know some people that are like so bad at basic math, like a colossally bad. And they'll look at a 9x9 Sudoku and say, I already got it.
My mom's that way.
Yeah, I so many guys. And they're like, well, why aren't you good at this? Like, because it's not math. It's a completely different, that's like saying you can run really fast, so you should be able to ice skate really fast. It's totally different. That really bothers me because I play hockey with really fat, dumpy dudes that if we were on ground, I would literally run circles around them while they were running down the field. But put them on ice, and I look like a moron.
You got more momentum.
It's unbelievable. These dudes turn into, it reminds me of the hippos doing ballet in Fantasia. Yes, I play hockey with Radna all the time. He's so good. He's stupid good. You have no idea how good he is. Huh? He's so good. He rides his bike from Mission every day. And he doesn't live down on the flats in Mission. Huh? Probably. All right, we all good?
Yeah.
Okay, turn the page over, and now we get to a math problem. A math class problem, because this isn't a real life problem, right? Okay, this question actually takes everything that you know of math from grade 8 onwards. Read the question. We've got a right angle triangle, we've got sides, and we've got an hypotenuse. What are we going to have to do? If I have the sides of a right angle triangle and a hypotenuse, what am I going to have to do? Pythagoras. There's grade 8. To do Pythagoras of a binomial, what must I do?
Tediousness.
FOIL. There's grade 9. Right? Actually, that's grade 10. Right? To find the answer to a Pythagoras question, what must I do at the end? Square root. Well, I must be finding roots of binomials, yes? There's grade 11. Cool? Yeah. Now wait for it. When you do a quadratic equation, how many answers do you get? 2. How many lengths can an hypotenuse have? 1. Only the hypotenuse can only have 1 length. What will happen then? I don't know. Let's find out. So, what do I know about the two sides? What do I have to do with them?
You have to square them.
I got to square them. So one side is x plus 2, yes?
Yep.
And what is happening with that?
Square.
Squaring it. Then according to Pythagoras, what do I do with the other leg? I add it. What's the other leg? 5x minus 3, also squared. What will that equal? 4x plus 1 squared. Holy crap, Mr. Myers, I don't know what to do with that. Yes, you do. What should you do with that?
Lots of foil.
Lots of foil, lots of collecting like terms, lots of factoring. So let's go. What's the first one? Do I have a shortcut to factor that?
Yeah, we do.
What is it?
You multiply and get the land.
Adam
Adam
plus 4x, multiply and plus 4, yeah? Right?
Yep.
Plus, do this one. 25x squared minus 15 minus 15 minus 30x plus 9, yeah? What? Yes, of course. Equals 4 times 4, 16x squared, plus 4 plus 8x plus 1. Is everybody good to there? Some of you are still foiling. That's okay. Continue to foil. When you've practiced FOIL enough, if you practice FOIL enough, you too will be able to do that in your head. Where math is done.
Wait for
See what I did there? Yeah.
is the shortcut with the number in front of x just
Multiply and add them. So 5 times negative 3 is negative 15. You got to do it twice.
yeah.
So it's negative 30. 4 times 1 is 4. So you got to do it twice. So it's 8. Everybody cool? What's my next step? Collect like terms. So on the left, I have 26x squared. The x squareds are gone. I have minus 26x. The x's are gone. And I have 13. Correct? Now, looking at that right now, is there something you could do with that right now if you wanted? You could factor out a 13, couldn't you? I would not do that yet because there are more x's over here. 16x squared plus 8x plus 1. Now what? Move everything to one side. What is the thing I said you should keep positive? The x squared. There's 26 there, there's 16 there. Which way am I moving? To the left or to the right? To the left. I'm moving stuff from the right to the left. Because once this comes over the equal sign, it's going to be minus 16, yes? So 26 minus 16 gets me 10x squared, right? What's this one going to be? Minus 34x. What's this one going to be? Plus 12. And what does all that equal? 0. Now what? Whoa. Look closer. Whoa. Take out something. What? GCF. What? 2. 5x squared minus 17x plus 6. Now, does this 2 matter? Do you think? We're going to end up with something times something equals 0, yes? Do I need that too? I need it in factoring. I don't need it to find an answer. Right? So now what would we do here? I'm going to have, if you factor my way, I'm going to have x. Since that's positive, it has to be minus and minus, yes? So I need numbers that multiply to what? 30 and add to negative 17. What is it? Negative 15 and negative 2. Over what? 5 and 5. What does negative 15 over 5 simplify to? 3. And this stays, yes? So what are my possible x's? Positive 3 and positive 2/5, correct? Everyone agree? Okay, I've got my 2 answers. Mathematically, am I done? Mathematically, I'm done. I can't do anything more. But have I answered the question? No. Why? I can only have one length and hypotenuse, can't I? Right? So what must I do with these 2? Check them. Where?
At the very first.
Do I have to go to the very first? Or can I go right there?
Well, you can go there. Well, that is...
Technically that, yeah, you're right. So put in 3. What's 3 plus 2? 5 squared plus, what's 5 times 3? 15 minus 3 is 12 plus 2, or times 12. 5 squared plus 12 squared equals 4 times 5 is, or 4 times 3 is 12 plus 1. So that's 13 squared. Does that work? 25 plus 144 equals 169. Does that work? So is 3 my right answer? 3 is a right answer. Now, do I need to check the other one? I can only have one length of a hypotenuse, can't I? This is where real life comes into play, yes? This is like, do I need to check a negative time? No, I don't even need to check it. But if I wanted to check it, could I? I would just put that in right there. Right? Everybody cool? That's quadratic equations. They get no more difficult, but they get more complex. Do you understand? Yes, Mr. Doolittle. No. The office doesn't know how to read a timetable. Christina Lee was in my Block A class in first semester. It's pretty complicated, guys. It's a spreadsheet, all right?
We've been over how people are bad with spreadsheets.
We have.
This discussion 2 weeks ago.
We did.
You were very angry.
I was. I'm not always angry, Kelvin. Listen, guys, you got to understand something about me. We live in the time when there is no excuse for not knowing something. Is there?
Well, I mean,
No. Bryce, anything that you do not already know right now, you do not know it by choice. Because every piece of human knowledge and understanding is available to you in your damn pocket at any given moment. So if you don't know how to do something, whose fault is it? Ours. Do I know how to fix a car? No. You know why? Because I haven't chosen to watch the right YouTube videos. Kelvin, what happened in physics today in X block? Did I know how to do physics? What did we do? We found the answers. Right? There is no reason. 100 years ago, oh my gosh, how did those Wright brothers get that plane in the air? But now, well, obviously, the air pressure going over the top of the wing has to equal the air pressure going under the wing, which creates lift, because that air has to be there because energy must be conserved. Duh! So when I sit in a school filled with people that are supposed to teach you people how to live that can't do simple tasks, how frustrating. Really. Right? How hard is it to find a kid? How many times has that phone rang while you've been in my class? Is Jason there? No, this is block C. Right? Do I ever walk in here and start teaching you guys Math 9? No, you know why? Because this is pre-calc 11. And I know this is pre-calc 11. You have a test tomorrow.